Alright, so this is the introduction to the rectangular coordinate system. That's just a fancy word for graph. So don't be intimidated by that. Alright, let's go ahead and move on. So a lot of things are set up in the grid system. And whenever you use a grid, typically you will look left and right first, and then you'll look up and down. So if I wanted to talk about, let's say, the engineering building here, then I would say that the engineering building's location is at 3, what is wrong with this? Hold on just a second. Okay, sorry, I think I got my pen working now. Alright, so if we wanted to give the location of the engineering building, we would say that the location is 3B. So you go left and right first, and then you use your up and down, and I'm looking at this right here and this right here. So Tiger Field is at 4C. Parking garage up here in the top left is at 1A. Alright, so I think you get the point of this. Okay, so this page right here is a page that I am going to give you a blank graph on the final test, and I'm going to ask you to label all of these things. I'm going to ask you to label the x-axis, which is your horizontal axis. I'm going to ask you to label your y-axis, which is your vertical axis. I'm going to ask you to label the origin, which the ordered pair that goes with the origin is 0, 0, and that is right there in the center. And there's 4 more things I'm going to ask you to label, and let me show you. So I'm going to ask you to label the quadrants as well. These quadrants go in, looks like a C. So quadrant 1, quadrant 2 is the top left, quadrant 3 is the bottom left, and quadrant 4 is the bottom right. So it goes like this, like that. Okay, so I will ask you to label all of the things on this page, plus I will ask you to label all 4 of the quadrants. Okay, whenever we talk about an ordered pair, typically that is written like this: x, comma, y, and those are going to be numbers. And x is your horizontal axis. Remember, that comes first, horizontal, and then y is your vertical. That comes second. So let's take a look at something like that. Okay, so we're going to plot these 2 points. The first point is 1, 3, and the next point is 3, 1. Now, I know that they're using the same numbers, however, notice that the numbers are reversed. And since the numbers are reversed, they're not going to be at the same location. So 1, 3 means you go right 1. Because it's positive 1, you're going to go right. Your left is your negatives. And because that's a positive 3, we're going to go up 3. So right 1 and up 3 is right here. And typically we'll label them with some sort of alphabet, so we'll call that one letter A. You don't have to do that. You could just write next to it 1, 3, that's fine. But it's just so much cleaner if you use a letter of the alphabet. So the next one, we're going to call it the letter B. And this means right 3 and up 1. So 1, 2, 3, up 1, and it is right here. Alright, so these already have little letters next to them. So the small a, that's negative 1, 3, that's left 1 because it's negative, and that's a positive, so we're going to go up 3. So left 1, up 3 is right here. And I'm going to use the little letter A. Little letter B, negative 3, negative 4, that's left 3 because it's negative. And because the negative 4 is negative, we're going to go down 4. Alright, so left 3, down 4 is, let's see here, 1, 2, 3, 1, 2, 3, 4, right here. So then I'm going to put a little letter B next to that. C, 2, negative 3. That means right 2, down 3. So right 2, down 1, 2, 3. Okay, now notice on D, little letter D, we've got 3 and 5 over 2. It's so much easier to graph this if you have either a decimal or you can see what the mixed number is, but I typically turn it into decimals whenever I have fractions. So I would do that as 2.5. And we can still graph that even though all of these lines are whole numbers. We can still go up halfway past 2. So this means right 3 and up 2.5. 1, 2, 3, 1, 2, and then I'm going to go up just a little bit right there. So I went up about halfway. So that is 3 and 5/2. Okay, so notice there's a whole bunch of 5s and a whole bunch of 2s on here, but all of these are going to be in different places. So let's look at part A. Negative 5, 2. That means I'm going to go left 5 and up 2. 1, 2, 3, 4, 5. 1, 2. And that is right there. And I'm going to put the little letter A there. On B, left 5, down 2. So left 5, down 2. And I'm going to put the little letter B there. 5, 2, that means right 5 and up 2. That's right there. So that's part C. And then 5, negative 2, right 5, down 2 is down here. Okay, it's always the zeros that seem to mess people up. And so on part A, 0, 5 means we go left or right 0. So we don't move past the origin going left or right, but we do go up 5. So stay there on the y-axis and go up 5 and put a dot. And that is 0, 5. 4, 0 means I'm going to go right 4, but I'm not going to go up or down any. So 1, 2, 3, 4. So this is my part B. On part C, I'm going to go left 3, but up or down none. And on part D, 0, 0, that's our origin. So I'm just going to put a dot right here, label it D. And on part E, 0, negative 1, that means I go left or right 0, but I go down 1. So here's part E. Okay, so now we're going in the other direction, and we're going to name the ordered pair. So that means I want you to give me an X and a Y. And it's important that you put parentheses around that. That's how we say that it's an ordered pair. So on part A, I go left 1, 2, 3, so negative 3. And I have to go up to get to A, and that's a positive 3. So on part B, I have to go left 1. And I have to go down 3. On part C, I go right 2 and up 4. And on part D, I go right 4 and down to negative 4. Okay, again, it's always these zeros that tend to mess people up. So on part A, you do move left or right, so we are going to have something in the X position. 1, 2, 3, 4, and that's going to be a negative 4. But we don't go up or down any, so we have to name that 0. On part B, you go left or right 0, but you go down 2. On part C, you go right 3 and up or down none, so that's a 0. And on part D, you go left or right 0, but you go up 1. Notice how whenever it lies on the y-axis, you always have a 0 in the x position. And whenever it lies on the x-axis, you always have a 0 in the y position. Okay, so this really isn't all that different from what I've taught you in the past, except now I want you to notice that we have an x and a y in the equation. But we are wondering which pairs are solutions. Here's an x and here's a y, here's an x and here's a y, and here's an x and here's a y. Now, I do want to warn you that there is more than one correct answer, because we're talking about a line here. I know I haven't shown you that on a graph yet, but there are an infinite number of possible solutions. So just because you find one that works doesn't mean you can stop there. You still need to go on and check the others. So on part A, we're going to put 0 in for x and 2 in for y, and we're going to see if it makes a true statement. So 0, this is part A, plus 4 times 2, does that equal 8? So 0 plus 8 is 8, 8 equals 8, so you would say yes, that is a solution. On part B, I'm going to put 2 in for x and negative 4 in for y and see if that makes a true statement. So 2 plus 4 times negative 4, does that equal 8? 2 plus a negative 16, does that equal 8? 2 plus negative 16 is negative 14, which does not equal 8, so you would say no, not a solution. And on part C, we're going to put negative 4 in for x and 3 in for y, and we're going to see if that creates a true statement. So I've got negative 4 plus 4 times 3, does that equal 8? So negative 4 plus 12, does that equal 8? Negative 4 plus 12 is 8, so I would say yes on this one. So just so you know, it is possible for all of them to be solutions. It's also possible for all of them to not be solutions. But you have to try each and every one of them. Okay, this one is basically the same thing. We're going to put on part A 0 in for x and negative 1 in for y. We're going to see if it creates a true statement. So I'm using this equation right here. The y comes first, so I'm going to put negative 1 in the y position. 5 times 0 minus 1, does that equal that? Negative 1 is equal to 5 times 0 is 0. 0 minus 1 is negative 1. So yes, I would say that is a solution. On part B, I'm going to put 1 in for x and 4 in for y. So I've got 4 is equal to 5 times 1, actually I'm going to put a question mark there, 5 times 1 minus 1. So 4, is that equal to 5 minus 1? 4 is equal to 4, so I would say yes on that one as well. Alright, let's try part C. We're going to put negative 2 in for x and negative 7 in for y, and we're going to see if that works. So negative 7 is equal to, we don't know, 5 times negative 2 minus 1. So negative 7, is that equal to negative 10 minus 1? I don't think so. So I would say no on that one. Okay, so in this one we are going to complete this table. They're giving us the x values that they want us to put in, and we're going to see what we get out for y. So on this first one, I'm going to put 0 in for x. So I've got y is equal to 4 times 0 minus 2. So y is equal to 4 times 0, 0. 0 minus 2 is negative 2. So I would put negative 2 right here. Now we have an x and we have a y. So that means later on, whenever we go to graph this, we have a point at that location. So now I'm going to try the next one. I'm going to put negative 1 in where I see x. Y is equal to 4 times negative 1 minus 2. So y is equal to negative 4 minus 2, which is negative 6. So I also have an ordered pair at negative 1, negative 6. Okay, so now I'm going to try the last one. So y is equal to 4 times 2 minus 2. Y is equal to 8 minus 2. So y is equal to 6. So I have an ordered pair at 2, 6. Okay, on this one, we've got our x's and y's on the same side. It doesn't really matter. They're telling us that they want us to put 0 in for the x position, and that means we're going to solve for y. So I'm looking for this number right here. So I've got 5 times 0 minus 4y equal to 20. Now I want to solve for y. That goes away, so I'm left with negative 4y is equal to 20. Divide by negative 4, y is equal to negative 5. So I have an ordered pair or a dot at 0, negative 5 if I were graphing this. Okay, let's try the next one. Now they're telling us to put 0 in for the y position. So I've got 5x minus 4 times 0 equals 20. That goes away. 5x is equal to 20. Divide by 5. X is equal to 4. So that means I have an ordered pair or a dot at 4, 0. Now they just picked 5, randomly picked 5, and they put it in the y position, which is fine. We can pick any numbers we want and solve for the other one. So I'm going to put 5 in where I see y. So I've got 5x minus 4 times 5 equals 20. 5x minus 20 equals 20. I would add 20 to both sides to solve for x. Divide by, what am I doing? I'm giving you the answer, sorry. Divide by 5, x is equal to 8. So that means I have an ordered pair at 8, 5. Okay, so we don't have a table. They say just find a solution to the equation 3x plus 2y equals 6. Now, guess what? That means that every single person in the class can give me a different answer, and every person can be correct at the same time. So, you get to pick, you want to put something in for x or do you want to put something in for y? I don't really care, but I'm going to pick that I'm going to put 0 in for x. I pulled that number out of the air, okay? And I try to pick things that are nice to me. And putting 0 in for either x or y, 9 times out of 10 is always nice to me. So I'm going to say let x equal 0. So that means I'm going to find, sorry, not written very well. So I'm going to find my y. So I'm going to put 3 times 0 plus 2y equals 6. That goes away. I've got 2y is equal to 6. Divide by 2. Y is equal to 3. Now, here's my x and here's my y. A solution for this equation right here is 0, 3. That's one solution. You guys can put in anything you want. So if you want to put in, let's say, 0 for y. Let y equal 0. So you could have done that. 3x plus 2 times 0 equals 0. That goes away. Oh, whoops. Hang on. equals 6. There we go. Okay, so I've got 3x is equal to 6, divide by 3, x is equal to 2. So I've got my x, I've got my y. Another solution would be 2, 0. Now, like I said earlier, there are an infinite number of solutions. You could all find different solutions and still be correct. But the point is, later on, whenever we go to graph these, they're going to line up in a straight line. No matter what point you pick, your point, as long as you did the math right, should line up with my point. Okay, so this says find 3 solutions to the equation x minus 4y equals 8. So typically what I do is I'll draw a table that looks like this. X, and then I'll put my equation right here. And then I'll put what I get out right there, and then I'll do my ordered pair at the end. So, what I do here is I pick values that are nice to me. Putting 0 in for x, usually pretty nice to me. So I'm going to put 0 in for x, and I'm going to solve. So off to the side here, that goes away, so I've got negative 4y is equal to 8, divided by negative 4, y is equal to negative 2. So I've got an ordered pair, or a dot, at 0, negative 2. Now, another one that would be nice to me is 0 for y. So I'm going to put 0 in for y. So x minus 4 times 0 equals 8. That goes away. So I've got x is equal to 8. And I didn't write anything in there, but you saw what I did off to the side. So I have an ordered pair at 8, 0. Okay, so it says they want 3 solutions. I found 2. So, let's see here. What other number would be nice to us? We can pick anything. How about 1 in for x? Now, that might give us a fraction answer, but that's okay. We can deal with fractions. So if I put a 1 in for x, I've got 1 minus 4y equals 8. And so I'm going to have to solve that. Subtract 1 from both sides. I get negative 4y is equal to 7. Divide by negative 4, and I've got that y is equal to negative 7/4. Now, if I were to plot that on a graph, I would turn that into a decimal first. So, but nonetheless, these are 3 solutions to that equation. And whenever I show you the answer page on the next page, they easily could have used other points. I'm guessing that they used 0 for x and 0 for y, but this last one they may have used something else to get a whole number answer there. We'll talk more about that later.